All right, so last section we're going to look at in chapter 1 is 1.6. And it's on different ways that we can take two functions that we have and combine them together to create something new. So I'll give you two functions, and we're going to combine them together to create a new one. Now there's four basic ways you can combine two functions. You can add them, subtract them, multiply them, and divide them. Those are the basic ways. We'll go through those first, and then we'll talk about a fifth way that you can combine two functions together, which is called composition. So just to show you a really, really simple example before we jump into one that has a few more steps to it. Let's say you had f of x equals 2x and g of x equals 3x. And I said, I want you to combine these two functions together to create a new function. And I want you to add them. So we're going to create a brand new function by combining the two that we already have. And I'm asking you to do it with addition. If you added f of x to g of x, what would you get? Yep.
You would plug, and would you plug it in for x?
Well, this is f of x, so that would go in that spot. And that's g of x, so that would go in that spot. Yeah?
You get 5x.
You get 5x. So that's an example of what we're doing. We took two functions, combined them together. This time it's with addition. Now, the other thing is, these were like terms. So we could add them up. You get 5x. Now, if you had something like 2x as one of your functions, and 3x squared is the other one, and I said to combine them with adding, well, when you combine them, all you can write is 2x plus 3x squared. Those are not like terms, so you can't do anything with it. And that will happen a lot. All right, so here's two functions. F of x equals x squared, and g of x is the square root of x plus 1. And I want to combine these by adding them. First, are they like terms? X squared and the square root of x plus 1? No. A like term would be like x squared and 5x squared. So when you add them, you get 6x squared. Okay, but those aren't like terms. So there's not really a lot to do. Does anyone think they can tell me what you get when you write f of x plus g of x? Yeah?
X squared plus the square root of x plus 1.
Yep. That's all you can do. They're not like terms. All right. How about if I wanted to write f of x divided by g of x? How would I write that one? Yep.
You'd write x squared over the square root of x plus 1.
Yeah. Again, there's nothing I can do with that. Now, if it was something like x squared over 3x, that can be simplified. Because think of it this way. X squared means x times x. 3x means 3 times x. And what do they both have in common in the top and in the bottom? 1x. So you could write that as x over 3. But in this case, can't do that. Right, and there's more examples of that on page 58. So when we started, this function has a domain, right? It has numbers that you're allowed to plug into it. This function also has its own domain. Maybe different, maybe the same. But there are numbers you are allowed to plug into this. When we combine them together to make a new function, that function also has its own domain. And that's what we want to be able to figure out. So the idea of what is the domain of the new one? Let's say this represents all the numbers that work in your first function. All the numbers you're allowed to use. Let's say this represents all the numbers you're allowed to use in your second function. The domain is all the numbers that would work in both. It's the overlap. All the numbers that you could plug into the first one, and all of the numbers that you could plug into the second one. It's the numbers that are in both domains.
But if they're both like all real numbers, then wouldn't the domain be all real numbers too?
Yes. Yep. So if you started out with two functions that were all real numbers and you combine them together with adding, subtracting, or multiplying, you do still have all real numbers. I left dividing out because think of this one that I just did up here. No, actually I need it the other way. Let's say you ended up with something like this when you combined two functions together. Whenever you combine two functions together with division, you have to be careful that you never what?
Use a zero.
Where?
Underneath.
Underneath. So if you combine two functions together with division, you are potentially creating a fraction where you never had one before because you used division. If you create a fraction and a variable somehow ends up in the bottom, you can never divide by zero. So like I would say the domain of this is every number except 0. So we're gonna go through a few of those right now. So we can't divide by 0. And what's the other thing that you're not allowed to do? So I always keep saying there's two things. Dividing by 0 and yep, can't do the square root of a negative number. Those are the only two things that you have to look for when you're figuring out the domain. Make sure you don't divide by 0, and make sure you don't take the square root of a negative number. So we have two functions. We're eventually going to combine them together by adding them. But first thing I want to do before I combine them is figure out what the domain is before I combine them. Square root of x plus 3. Does that have something in it that I have to be careful about?
Yes.
Yes? What?
I don't know. I said no, and then you didn't say that's correct, so I changed my answer.
Max?
If x is like a negative number greater than 3,
It'll what?
it'll make the whole number negative.
Right, so we don't want to take the square root of a negative number. Both of those functions have square roots in them. Because they have square roots, the domain is not all real numbers. You could not plug in negative 10 for x. Negative 10 plus 3 is negative 7. Can't do the square root of negative 7. So I'm interested in what numbers I can use. Square root of 0 is fine. You can do the square root of 0. I think people mix that up with dividing by 0, which you can't do. But square root of 0 is 0. That's okay. So does anybody see what numbers I could fill in for x in the top square root? Yep.
X needs to be greater than negative 2.
What about negative 2.5?
Sure. Well, like as long as Or x negative 3.
Negative
X is
3.
Greater than negative 3.
So you could do negative 2.9 or equal to. You could do negative 2.999. You could do negative 3. You can't do like negative 3.1. That wouldn't work. So the domain, two ways we can write it. We could write anything greater than negative 3. So you can write low value, comma, and then the high value. The low value is negative 3, and the highest value you can use is infinity. When you put a bracket on the number, that means you can include negative 3. If I put a parenthesis, that means I cannot include it. So that would mean I could go as low as like negative 2.9999999. Okay, so bracket means include, parenthesis means not include. I put a parenthesis on infinity because you can never reach infinity. Okay, by putting a bracket on something, you're saying you can reach that and be equal to it. Well, you can never equal infinity. So is there any question on that notation? Okay. How about this one? What values could I plug in for x in that one? Yep.
2. And anything really above 2.
Anything above 2?
Positive 2.
Okay. I agree. That's most of what you can plug in, but there's something else. You said everything above positive 2, right? Okay. Yeah?
Or equal to.
Or equal to. So anything from the number 2, that's the lowest you could go, including 2. And you can go as high as you want. Couldn't plug in anything less than 2. Try plugging in 0, and you'll see it doesn't work. Yeah?
You're talking about like there's two ways to write the domain, right?
Yeah, so the other way would be like this.
Okay, yeah, that's what I did, so I was wondering.
Depends on what the question asks for. This is called an interval. This is called an inequality. But this means that.
Yeah.
Right, now let's combine them together. Well, there's not a lot that I can do when I combine these together. Specifically, I'm combining them by adding. And that's it. So it's the square root of x plus 3 plus the square root of x minus 2.
Why can't you combine those?
Because they're not like terms. Like terms would be something like this. Square root of x plus square root of x. That would be 2 square roots of x. If these are different, then you can't combine them. Okay, so what's the domain here? What kind of numbers could I use? And they have to work here and here. They have to work in both, yeah?
Anything that's 2 or higher.
Yes, anything 2 or higher. If you think of it like a number line, right? The top one was anything negative 3 and up. That was the domain of the top one. The bottom one was anything from 2 and up. So what we're looking for is the overlap, the numbers that would work in the top one and the bottom one. That's everything from 2 and up. So that's your domain. 2 to infinity. All right, so let's take the same two functions again. And what would be the formula if I divided them? Yeah, now.
Square root of x plus 3 over the square root of x minus 2.
Yep. So there's the formula for combining them. Now I want to know the domain. Would it be the same domain as what's up above?
Yes.
Yes?
I think yes.
You think yes? Declan, what do you think?
You can't include 2.
Why?
Usually only 0 denominator.
Right. We include 2 this time. It's not a problem to do the square root of 2 minus 2. That's the square root of 0, which is 0. What is a problem is this fraction. You can't divide by 0. So we are not allowed to use the number 2. So this time domain is everything from 2, not including 2, to infinity. Any question why you can't use 2 this time? It's all because we created a fraction where we never had one. So we have to avoid dividing by 0. All right. Let's try this one. So it says to graph it, so we're going to use the calculator. And then find the domain and the range. Well, before we graph it, we can do the domain. So this is the absolute value of x divided by x. This time, there's only one number you can't use. Does anybody see? Yeah?
0.
Yeah, you can use everything except 0. You can take the absolute value of any number you want. Positives, negatives, fractions, decimals. You can plug in any number you want into the bottom of a fraction except the number 0. So this time the domain is everything except 0. There's 2 ways to write it. That's one way. That's as like an inequality. Or think about what that would look like on a number line. Here's 0. You can pick anything you want that's lower. You can pick anything you want that's higher. The only thing you can't pick is 0. That's what the domain would look like as a picture. So if you wanted to write this as an interval, like we did the last problem, you'd have to write it in 2 pieces. You could do that as the first piece, and that is the second piece. So the first piece is everything as low as you want to go, up to, but not including the number 0. The second piece is everything from the number 0 as high as you want to go, not including the number 0. And whenever we have 2 pieces like that, we put that symbol between them. This symbol means or. So you can pick anything as low as you want to go, below 0, or as high as you want to go, above 0. You just can't pick 0.
So that's the domain.
Yep, that's the domain as an interval. That's the domain as an inequality. They both mean the same thing. So let's graph it, and that's going to help us figure out the range. Okay, so let me label this. That's the domain. Okay, so let's go to y equals. I think I showed you guys yesterday where absolute value was. It's under math, number, absolute value. Absolute value of x, I need to hit the right arrow, and then divided by x. The divided by x is not in the absolute value. Let's do zoom 6. And that's the graph we get. So think about that for a second. If you plugged in 5, what's the absolute value of 5? 5 divided by 5? 1. How about if you plugged in 6? What's the absolute value of 6? And then divide by 6? 1. So if you plug in any number bigger than 0 for x, you're always going to get 1. Now let's try like negative 2. What's the absolute value of negative 2?
2.
2. And what's 2 divided by negative 2? Negative 1. So this graph only has 2 values in the range. No matter what you plug in, you're going to get one of 2 answers all the time. 1 or negative 1. That's your range. 1 and negative 1. So range here. Since the range only has two numbers in it, we can write every single number. If the range was something like every number greater than 0, you can't write down every single possible number greater than 0. That's why we write it as an interval. But with the range, you can do this. This symbol means that what you're about to write down now is a set of numbers. And the range includes the number -1 and +1. And that's it. 2 values. If you tried to go to 0, if you go to the table, type in 0. I don't know if you can see it, but it says error. You can't plug 0 in for the domain because it would cause you to divide by 0. But that's the only number you cannot use.
Which button is that?
What's that?
Which button is that?
To get to the table, second table.
Ah, I can see it.
Let's press second table. Okay, so any questions on combining two functions together by adding them, dividing them, things like that? Okay, so the last thing we're going to look at combining two functions together is composition. The simplest way to explain it is you take one function and plug it into the other. That's what you're doing. We'll go through how to do that. So let's just jump right into one so I can show you how it works. So g of x is the square root of x, and f of x is x squared plus 3. I'm not going to take these two and put a plus sign between them or a minus sign or a divide by sign. I'm going to compose them. And specifically, I'm going to compose them by finding what's called g of f of x. That's how you pronounce this. G, and then everywhere you see a parenthesis, you say of. G of f of x. So the first step is to write this. G of, and we're going to be using f of x. What's my formula for f of x? Yeah. X squared plus 3. That's f of x. So what this means to do is look at the formula for g, and everywhere you see a variable in the formula for g, replace that variable with what's in the parentheses. If this was a number, like g of 2, I would say plug 2 in for x, and the answer would be the square root of 2. If g was 6, you'd plug in 6, and the answer would be square root of 6. If g is x squared plus 3, then the answer is the square root of, and we fill in x squared plus 3. That's an example of a composition. We took this and we filled it in for the variable. Now, we can also do it the other way. We can take this and fill that in for that variable. So that's composing it the other way. So now, let me show you how you write it, and then I'll show you how to do it. So the first one was g of f of x. This is f of g of x. So keep the letter on the outside the same. And change what's on the inside to what your formula says. What's our formula for g of x? Square root of x. So now, if this said f of 2, I would take in the f formula, bless you, and everywhere that I see a variable, I would change it to a 2. If this said f of 5, I would take the f formula and change all the letters to 5s. This one says, take the f formula and change all the letters to this, square root of x. So can anybody tell me, you don't have to simplify it, but just tell me what I would get if I take this and fill it in to the f formula. Yep.
The square root of x squared plus 3.
So we're changing x to square root of x. So square root of x squared plus 3. And what does that simplify to?
X plus 3.
X plus 3. And that's another example of a composition. Any questions on, we're going to do a few more, but any questions on those two? So the composition part, where you plug one into the other, that's usually the easier part. What can be a little trickier is making sure we can figure out the domain and the range. Okay, the calculator can help us with the range, but the domain we have to figure out. Now, the notation that I gave you guys, that's always the notation that I'm going to use. There is another notation you might see in the book. You might see a letter, a little circle, and then another letter. If you see that, it means the same thing as what I showed you. Okay? I don't write it this way. You're not going to see it that way on the test. But if you see it in the book somewhere, this means that. All right, so how do we find the domain? It's a little more complicated than just saying it's the overlap. Like if you picture that Venn diagram I drew the first time, and like it was the overlap, it's a little different. But it's only 2 steps. When you compose 2 functions together, one of them I refer to as the inner function, the other one is the outer function. I'm just trying to give you an example of one. Let's just go back to this one. If you look at this, I would say the inner function here is g, and the outer function is f. Okay, so the inner function is inside the parentheses, the outer function is the one in front. To find the domain, the first thing we want to do is look at the inside function. When you look at the inside function, first you want to exclude any values that would not work from that. So you're going to be looking for 2 things. In the inside function, did you divide by 0? Could you take the square root of a negative? If either one of those things could happen, tell me the values I could use so it doesn't happen. I don't want that to happen. So we'll see if there's any issues with the domain of the inside function. And step 2 is to look at the final answer. When you look at your final answer, does the final answer have a square root in it? Or does the final answer have a fraction in it? If it has either one of those, we need to make sure we don't divide by 0 and we don't take the square root of a negative. Sometimes doing step 1 is enough. Step 2 doesn't give us anything new that we have to be careful with. Sometimes it does, sometimes it doesn't. But these are the 2 things you have to check. Check the inside function and then check the final answer to the problem. And we'll try that right now. So here's our two functions. F of x is x plus 1, and g of x equals the square root of x. What I'm going to do first is let's take a step back and let's just try plugging a number in, just to get the idea of composition. You're still not kind of sure on it. I think doing it with a number rather than a letter may help it to make more sense before we continue with finding domain. So the first problem says to find f of g of 9. You start on the inside and you work your way out. So nothing's going to happen to f right now. On the inside, it says to take function g and plug a 9 into it. What do I have for function g? What's the formula? Yep.
Square root of x.
Square root of x. And we're going to replace the x with 9. Okay, so we're just trying it with a number. Now you simplify what you can, and you get 3. Now we're at the outside function. It says to plug 3 into the f formula. What do I get if I plug 3 into function f? 3 plus 1. Excuse me. 4. That's composition. We've been doing it with letters, but that's exactly the same thing with a number.
Would you get like one final answer? So like 4 would plug in for f?
4 is the final answer.
Oh.
That's it.
Oh.
You'll get a number answer if you start with a number that you plugged in. If you start by plugging a letter in, then you won't. So let's try it this way now. Instead of doing f of g of a particular number like 9, let's do f of g of a particular letter like x. Okay, so start with the inside. What's my formula for g of x? Square root of x. Now, take the result that you just got here and plug it into f. What would I get if I plugged in square root of x into f? Jess?
Would the square root of x stay in parentheses and then x plus 1?
You could keep it in parentheses. You don't need the parentheses. But the important thing is it does have to be square root of x plus 1. It can't be this. That would be wrong. So it's square root of x plus 1. All right, let's try it the other way. G of f of x. Sam, what's my formula for f of x?
X plus 1.
X plus 1. And what do I get if I plug x plus 1 into formula g? Got that?
Square root of x plus 1.
So same thing I had right here?
No.
No, what's the difference?
The 1 is included in the square root.
Yes. Big difference. If you think about it just from transformations that we learned yesterday, this would be a shift up 1, this would be a shift left 1. It's totally different. I know we only studied transformations with parabolas, but transformations work the same on every function. Parabolas, square roots, doesn't matter what you study. But those would be the answers.
I'll write the x squared plus
Because you're taking this and you're filling it in right there. So it's the square root of, and then replace the x with x plus 1. All right, so let's try one where we do the domain. This time I'll just do it one way. Let's find g of f of x. All right, so start with the letter on the outside. And Alexis, what is f of x in my case? Okay, so we're finding g of, look up what f of x is. X squared minus 1. Now fill x squared minus 1 into the formula for g. What would I get if I filled x squared minus 1 in for the letter? In g. Yeah.
With the square root and the exponent cancel out.
Let's just write it down first and then I'll explain that. So tell me what you would have before you try to do anything else to it.
The square root of x squared minus 1.
So the square root of x squared minus 1. Whenever you have addition or subtraction under the square root, you cannot cancel that out. Like if you had the square root of 9 plus the square root of 16, we know that the answer here should be 5, right? Because it's 9 plus 16 is 25, and the square root of 25 is 5. If you try to take the square root of each one of these separate, like if you tried to cancel out this exponent, you would have 3 plus 4 if you took the square root of each one separate, and that would give you 7. So you cannot take the square root of each thing separate. That doesn't work. So that's as much as you can do. Okay, domain. Step 1. Start with the inside function. X squared minus 1. In x squared minus 1, are you taking a square root? No. Are you dividing by a letter? No. So the two things that you are not allowed to do don't ever happen in the inside function. So the domain of the inside function would be what numbers? It's all reals. So from step 1, we have all real numbers. We didn't eliminate anything you couldn't use. Now let's look at step 2. Look at the final answer. Does the final answer have division with a letter in the bottom? No. Does the final answer have a square root in it?
Yeah.
Yes. So then there is a restriction. We never want to take the square root of what kind of number? Negative. So let's figure out what we would have to do to keep this positive. We want x squared minus 1 to always come out greater than or equal to 0. We do not want it less than 0. That means we want x squared to be greater than or equal to the number 1. What kind of numbers can you square? And they will come out greater than or equal to 1.
Negative.
What numbers?
Could you do negative 1?
You could square negative 1 and it would work. Yeah?
Would you do like all positive numbers?
Well, if you squared 0.5, that would not come out greater than or equal to 1.
All positive numbers greater than 1.
Or equal.
Or equal to.
So you could pick anything from 1 and up. And if you square anything in that range, you'll get a number greater than or equal to 1. And where else? Yeah?
Anything below negative 1 and or equal to negative 1?
Anything below or equal to negative 1. Like if you squared negative 2, you would get positive 4. That would work. So the only thing you can't use is in there. You can pick anything bigger than 1 and anything smaller than negative 1. and that's your domain. So the way we write it, two pieces, the left arrow and the right arrow. For the left arrow, the lowest number you could pick is negative infinity, and the highest number you could pick is negative 1. Can we include negative 1?
Yeah.
Yep. Or, for arrow number 2, the lowest number we can pick is 1, and we can include it. And what's the highest number we could pick? Infinity. That's how you would write the domain. Any question on the domain for that? All right, let's try. We'll do another one with domain, but let's do the range with it. So to figure out the range, we are mostly going to use the calculator. But you can't use the calculator unless you know how to set your window. So to find the range, the first thing you have to do is find the domain. The domain will tell you how to set your xmin and xmax on your window. Okay, it'll give you an idea. And then to determine the y values that you're going to get when you plug the x values into your formula, we're going to use the graphing calculator for step 2. So that'll be the graphing calculator. I have, for the next example, g of f and f of g. I'm not going to do both. I'm going to look at what the problem is. I'm just going to pick one. All right. Let's do the g of f. Let's do that one. Let's do that. Okay. Does everyone have the step 1 and step 2? Okay. Let me just scroll up so you can see the problem here. All right, so find g of f of x. All right, somebody tell me how do I do that? What would I write down, man?
You would have g of the square root of x.
Perfect. So what they want you to do is plug the square root of x in to function g. If I do that, what will I get? Yeah.
Square root of x, and then outside of the square root minus 3.
So now let's look at the domain. Start with the inside function, square root of x. Are there any restrictions on a square root?
Yes.
Yes, there are. What values would we have to pick for x here to make sure we follow those restrictions?
Everything except 0. No, sorry, not a negative.
Not a negative. So anything that's 0 or positives. Yeah?
Oh, I was gonna say it has to be like if you include the minus 3, it has to be.
Well, we'll get to that in a second. Hang on to that. But anything here, we could pick 0 and up. Now, keep that in mind, 0 and up. So we're already limited to that. Does the final answer have a square root in it?
Yeah.
Yes, then we need to check, is there anything new here that we have to be careful with? Declan?
No.
No. The minus 3 is not under the root. So if you pick numbers from 0 and up for that, that will work as well. So 0 and up works for the inside function. 0 and up works for the final answer. So the answer is everything 0 and up.
Wait, but can it not include 0? Because I thought the square root. Oh,
Square root of 0?
yeah.
It's
I'm
just
confusing
0.
Square root and division.
Yep, square root of 0 is fine. Divide by 0 is not. Okay. Now, Matt, I think what you were probably getting at is if we had something like this, that would be a little different. Then we could only pick numbers from 3 and up, because the 3 is under the root. But in this case, the 3 has nothing to do with the square root. Okay, so there's our domain. And to get the range, we'll graph it. So let's put in the square root of x minus 3. I'm just graphing the final answer. Let's do zoom 6. Now, technically, I shouldn't have my window set to -10 because I know my domain starts at 0. So I should have put my x-min on 0. It doesn't go below 0. And what that is it's a sideways parabola. Now, I can see that it starts at, looks like -3. But let's zoom more to the right. Let's let x equal 50. How high do you think this graph is going to go? Yeah? Infinitely. It's a sideways parabola. It's just going to keep going up slower and slower. So the highest it's going to go is what? Infinity. Yeah. So the highest is infinity. How about the lowest? Does it go down forever? No. Then what we probably want to do is zoom in and see. You can just go back to zoom 6. How low does the graph go? It looks like it is -3, and it is -3 because the square root function was shifted down 3. So it is -3, including. So range is how high and low it's going to go.
For this one in particular, do you need to graph it to know, or would you?
Like me personally?
Yeah.
I could do that without a graph.
Yeah.
Yes, because I know that a square root function always starts at the origin and looks like that. And I know that if you put a -3 on the end, it's going to move it down 3. So I could look at that and know. But the graph is there to help you if you don't know. All right. I'm not doing that. So what I want to do now to finish up is describe transformations, but this time I want to generalize them to any function. We studied them all yesterday for parabolas, but they work the same on any function. So we're going to kind of write down a list of general rules for transformations. Now, this says that A, H, and K can be any positive real numbers. That's what that symbol means. Technically, this symbol means element of. But it's A, H, and K can be any positive real numbers. So positives, zeros, fractions, decimals. And I'm going to use the letters A, H, and K down below. Let's do it this way. When you multiply by a number in front, like yesterday we did this, what does multiplying by a number in front do?
Maybe like stretch the rest of the graph.
Which way?
Vertical.
Vertical. Yep. When you multiply by a number in front, that's a vertical stretch or shrink. Doesn't matter if it's a parabola, doesn't matter if it was a square root. You multiplied by a number in front. It will stretch or shrink it vertically. How about if you add or subtract something on the end? We just did this with the square root. We had a -3 on the end of it. Okay?
Shift up or down.
Yes. When you add or subtract on the end, outside of the parentheses, that's up or down. How about if you add inside? Which way does that move? Yep.
Horizontal shift, left or right?
Which one is the plus?
Left.
The plus would move it left. And the minus would move it
Right.
right. Okay, we talked about negatives. A negative causes a flip or a reflection. If you put the negative out in front, does anybody remember which axis it would flip over? This one we didn't really study a lot with parabolas because it looked like the same thing. We couldn't tell that it happened. Yep. Yes. When the negative is in the front, think of this number, it would be right next to the vertical stretch. It would be a vertical flip, which is over the x-axis. So how about when you put the negative inside? Yeah?
Reflection go line.
Yep. All right. So in the last problem we look at, I'm going to give you a picture, and I'm going to ask you to transform it. So you have to know these patterns. I'm not going to give you an actual formula, like a parabola or anything. I'm just going to give you a picture. And I'm going to ask you to do something to it. Okay, so there's a graph. It's nothing special. It just has a point at -2, 0, 0, 2, and 4, 0. I'll make it so you can see a little better. And I want to do something to this picture. So you're not going to have to think about any type of like algebra. You're literally just going to draw a picture. This is what I want to do to the picture. You have to know what those numbers mean to do to it. The first one we would start with is the +1. What is the +1 going to do to that picture?
Shift it left 1.
It's going to shift it left 1. So take every point and move it left 1. That's the first step. So the +1 shifts it left 1. The next thing is the 2. What's that going to do? Multiplying by a number in front. Yeah, Caleb?
Vertical stretch.
Vertical stretch by how much?
2.
2. When you stretch something vertically, that changes the y values. It's going to double all my y values. What's going to happen to the y value of this point if I double? It stays right where it is. What's going to happen to the y value of this point?
4.
It's going to go up to 4. And the y value of this point stays the same. That's a vertical stretch by a factor of 2. Stretched it. And the last one is a -3. What's that -3 going to do?
Move it down 3.
Move everything down 3. Down 3. Down 3. So basically like that. So the blue picture is your final answer. That is the picture. Okay, so there'll be one like that and two like that in the homework. I think the shape they give you is more like this. And you just have to stretch it and move it. But that's the idea. Okay, any questions on it? What? Yeah, and since I have it all on the screen, you could pause the video right there too, and you can grab anything you need. So that's the homework for tonight. Okay, on page 66. I think it's about 12 problems or so. We will look at that tomorrow, and then tomorrow we will finish up everything for the week. Remember, progress reports close on Friday, so I will be doing your grades with whatever I have by Friday. I will be after school tomorrow if you need to see me pick anything up. Or you can come any period during the school day to come see me.
Is that a 57?
That's a 57. Yeah.